Hello everybody, this is the notes for section 6.4. Um, First hour, you've already started this a little bit, but for second hour, here's the idea. And for fifth hour, I don't know where we're going to get to. You guys haven't been to my class yet. So here's the idea. A couple months ago, we started talking about congruency. We started with just general shapes. So shapes would be congruent if all corresponding angles were congruent and all corresponding sides were congruent. And then we started talking about triangles. Okay, to get triangles to be congruent, you didn't need to have every corresponding side, every corresponding angle to be congruent. You just needed certain parts, side, 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 angle, side. Well, we're doing the same idea with similarity. Okay, two shapes, just generic shapes, are similar if corresponding angles congruent and corresponding sides have equal proportions. And so now that we're talking about triangles, well, we don't need to have all corresponding sides and all corresponding angles to get our similarity. So what I've done in this drawing is created two different triangles, but each triangle was created in the same way. One, I just drew a segment AB, I made a 60-degree angle and then a 50-degree angle on the other end of it. Where those angles met, that's our point C. Did the same thing for segment DE. Okay, 60-degree angle on the left side, 50-degree angle on the right side. Where those sides met up, that's our point F. And then I measured those side lengths, and what we're looking at down here are the ratio of those corresponding sides. So as I move point B around, changing the lengths of each of the sides of that triangle, you can keep your eye on those ratios. Okay, if I move point D around, you look at those ratios, they're all equal to each other. Oops. Okay, move the triangle around, those ratios are always staying the same. So what we have here are two different triangles, but all the corresponding sides have equal proportions. That's this 1.3 that you see for each of those three ratios. And all the angles are congruent, all the corresponding angles are congruent to each other. You got two 60-degree angles, you got two 50-degree angles. Third angles theorem forces angle C and angle F to be congruent. So we've got similar triangles, all right? All corresponding angles are congruent, all corresponding sides have equal proportions. But the nice thing is here, we didn't need all this information. What created these similar triangles were these two angles. I formed these triangles with a 60-degree angle and a 50-degree angle. And that is it, all right? Knowing that those two angles, those two pairs of angles were congruent, that created similar triangles. So, what we have is called angle-angle similarity. So just like the idea of the side angle, side, 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 those all things, those were towards congruency. We're talking about angle-angle similarity. And the proper way to write this will be angle, angle, and you put the little similar symbol after it. But what it says is, if two angles of one triangle are congruent to two angles of another triangle, that's going to force these two triangles to be similar. All right? This is our main theorem here. So take a second, copy that down. Okay. Are these two triangles similar? So we got three examples here. Looking at the one on the left. Notice we got parallel lines. All right, that means we got some transversals. So corresponding angles says that those two angles are congruent. It also says these two angles are congruent. So we've got two pairs of angles that are congruent. That means triangle JKN, the smaller one kind of on the top, that's going to be similar to triangle. And now don't forget about corresponding order. Okay, point J was first. Point J is the same in both of these triangles, so it will go first also. Angle K corresponded with angle L, and then N corresponded with M. So these two triangles are similar because of angle-angle similarity. All right, looking at the middle example. We have this line, or this segment, MO. Because of that right angle there, we have another right angle. So there's one pair of angles congruent. This information says we've got two pairs of angles congruent. And so now, angle, angle, these two triangles are similar to each other. So triangle NQ, that will be similar to triangle. So now, corresponding order. We didn't know anything about M. We don't know anything about O. Those are going to correspond. We went to M and then to N. N was the right angle in the smaller triangle. We're going to go to N also because that's the right angle there, which leads us up to point P. So these two triangles are similar, again, by angle-angle similarity. Okay? For this last example, we have one pair of angles congruent, angle B congruent to angle D. We've also got vertical angles. So, angle-angle similarity, now these two triangles are similar to each other. So, triangle ABC will be similar to triangle. We knew nothing of A, we know nothing of E. Those correspond. We went to B, that's the angle with the two arcs in it. D is the one with two arcs in it. So that's where we're going next. For triangle ED, that leaves us with C at the end. And again, because of angle-angle similarity, those two triangles are congruent. Now, once you have similar triangles, okay, if these two triangles are similar because of angle-angle similarity, then that gives us all these proportions to set up. And so that's what a lot of the homework is going to be. Here's these two triangles, they're similar. Now you set up these proportions and you solve for the missing side length or solve for x, whatever it is, okay? All that kind of stuff we've done a lot of that, so I'm not putting any examples up here, but that's the next progression of this. Yes, these triangles are similar, now set up your proportions. But I do want to do one story problem, and that picture's very hard to read, but what you're looking at, you can kind of see there's a lake in there, maybe. It says you can measure the width of a lake using a surveying technique as shown in the diagram. So basically, you know two numbers. You know 8 meters is that segment ZY. You know this 104 meters is that segment VW. And you've also got this distance. The 6 meters, that is the length from Z to X. All right, it says what postulate or theorem can you use to show that the triangles are similar to each other? All right, so let me get rid of those circles. Now, you notice those two parallel markings. Okay, one, we have vertical angles, so there's a pair of angles. But because of these parallel lines, we got alternate interior angles. So there's two pair of angles that are congruent. These two triangles are going to be similar to each other. And just to help with the correspondence, I'm going to write the similarity statement. Triangle ZXY is similar to triangle. All right, Z corresponded to W, X corresponds to itself, and then we go to V. So, these two triangles are similar because of angle-angle similarity. Now it says find the width of the lake, WX. So here's what I was talking about in the last slide. We got a triangle similar, so now we can set up these proportions. All right, side ZY. Let's see, we got ZY. Its corresponding side is WV. We're looking for WX. All right, that's in that bigger triangle, so that's going to be in the denominator. It corresponds to ZX. So, because the triangles are similar, we know these two ratios are going to be equal to each other. All right, ZY is 8. WV is 104. It will equal ZX, which is 6. WX is what we're looking for. All right, so now you can just cross multiply and solve. What we're going to get is WX will equal 104 times 6 divided by 8. I don't have a calculator handy, but you can do that. There's your answer for the length of WX, which is the width across the lake. Okay, so there's our answer for part B. Part C says if xy equals 10, find zx. Or vx, sorry. All right, so it's same idea. If xy is now 10, let me change the colors, maybe it'll show up. There's a 10 there, not really. It corresponds to xv, so that's an unknown there, but same idea. All right, we knew the 8 over 104, smaller triangle to bigger triangle, so that's going to be 10 over the segment x, or vx. Cross multiply and solve. All right, that's the gist of this. So we're just talking about shortcut ways to get two triangles to be similar. I'll see you in class. Have a good night.